What is the story of how you came to program Doom? What are some memorable technical challenges or innovations within that game?
So the path that we went after Wolfenstein got out, and we were on this crazy arc where Keen 1 through 3, more success than we thought. Keen 4 through 6, even more success. Wolfenstein, even more success. So we were on this crazy trajectory for things. So actually, our first box commercial project was the Commander Keen game, but then Wolfenstein was going to have a game called Spear of Destiny, which was a commercial version, 60 new levels. So the rest of the team took the game engine pretty much as it was and started working on that. We got new monsters, but it's basically reskins of the things there. And there's a really interesting aspect about that I didn't appreciate until much, much later, about how Wolfenstein clearly did tap out its limit about what you want to play, all the levels and a couple of our licensed things. There was a hard creative wall that you did not really benefit much by continuing to beat on it. But a game like Doom and other more modern games like Minecraft or something, there's kind of a Turing completeness level of design freedom that you get in games that Wolfenstein clearly sat on one side of. You know, all the creative people in the world could not go and do a masterpiece just with the technology that Wolfenstein had. Wolfenstein could do Wolfenstein, but you really couldn't do something crazy and different. But it didn't take that much more capability to get to Wolfenstein with the freeform lines and a little bit more artistic freedom to get to the point where people still announce new Doom levels today, all these years after, without having completely tapped out the creativity.
How did you put it? Turing complete?
Like Turing complete design space.
Design space.
Where it's like, we have the kind of computational universality on a lot of things and how different
for
substrates
creativity
work. But yeah, there's things where a box can be too small, but above a certain point, you kind of are at the point where you really have almost unbounded creative ability there.
And Doom was the first time you crossed that line.
Yeah, where there were thousands of Doom levels created, and some of them still have something new and interesting to say to the world about it.
Is that line, can you introspect what that line was? Is it in the design space? Is it something about the programming capabilities that you were able to add to the game?
So the graphics fidelity was a necessary part because the block limitations in Wolfenstein, what we had right there was not enough, the full-scale blocks, although Minecraft really did show that perhaps blocks stacked in 3D and at 1/4 the scale of that, or 1/8 in volume, is then sufficient to have all of that. But the wall-sized blocks that we had in Wolfenstein was too much of a creative limitation. We licensed the technology to a few other teams. None of them made, too much of a dent with that. It just wasn't enough creative ability. But a little bit more, whether it was the variable floors and ceilings and arbitrary angles in Doom or the smaller voxel blocks in Minecraft, is then enough to open it up to just worlds and worlds of new capabilities.
What is binary space partitioning?
So
which is one of the technologies.
Yeah, so jump around a little bit on the story path there.
Yes.
So while the team was working on Spear of Destiny for Wolfenstein,
yes.
we had met another development team, Raven Software, while we were in Wisconsin, and they had RPG background, and I still kind of loved that, and I offered to do a game engine for them, to let them do a 3D rendered RPG instead of like most RPG games were kind of hand-drawn. They made it look kind of 3D, but it was done just all with artist work rather than a real engine. And after Wolfenstein, this was still a tile-based world, but I added floors and ceilings and some lighting and the ability to have some sloped floors in different areas. And that was my intermediate step for a game called Shadowcaster. And it had slowed down enough. It was not fast enough to do our type of action things, so that they had the screen cropped down a little bit, so you couldn't go the full screen width like we would try to do in Wolfenstein. But I learned a lot. I got the floors and ceilings and lightings, and it looked great. They were great artists up there, and it was an inspiration for us to look at some of that stuff. But I had learned enough from that I had the plan I knew faster ways to do the lighting and shadowing, and I wanted to do this freeform geometry. I wanted to break out of this tile-based 90-degree world limitations. So we had, that was when we got our next stations, and we were working with these higher powered systems, and we built an editor that let us draw kind of arbitrary line segments, and I was working hard to try to make something that could render this fast enough. I was pushing myself pretty hard. And we were at a point where we could see some things that looked amazingly cool, but it wasn't really fast enough for the way I was doing it. For this flexibility, it was no longer, I couldn't just raycast into it. And I had these very complex sets of lines, and simple little worlds were okay, but the cool things that we wanted to do just weren't quite fast enough. And I wound up taking a break at that point, and I did the port. I did 2 ports of our games, Wolfenstein to the Super Nintendo. It was a crazy difficult thing to do, which was an even slower processor. It was like a couple megahertz processor. And it had been this whole thing where we had farmed out the work, and it wasn't going well. And I took it back over, and trying to make it go fast on there where it really did not have much processing power. The pixels were stretched up hugely, and it was pretty ugly when you looked at it, but in the end, it did come out fast enough to play and still be kind of fun from that. But that was where I started using BSP trees, or binary space partitioning trees. It was one of those things I had to make it faster there. It was a stepping stone where it was reasonably easy to understand in the grid world of Wolfenstein, where it was all still 90-degree angles. BSP trees I eased myself into it with that, and it was a big success. Then when I came back to working on Doom, I had this new tool in my toolbox. It was going to be a lot harder with the arbitrary angles of Doom. This was where I really started grappling with Epsilon problems, and just, up until that point, I hadn't really had to deal with the fact that so many numeric things. This almost felt like a betrayal to me, where people had told me that I had mathematicians up on a bit of a pedestal, where people think I'm a math wizard, and I'm not. Everything that I did was really done with a solid high school math understanding. Algebra 2, trigonometry, and that was what got me all the way through Doom and Quake and all of that, of just understanding basics of matrices and knowing it well enough to do something with it.
What's the Epsilon problems you ran into?
So when you wind up taking a sloped line and you say, I'm going to intersect it with another sloped line, then you wind up with something that's not going to be on these nice grid boundaries. With the Wolfenstein tile maps, all you've got is horizontal and vertical lines looking at it from above, and if you cut one of them, it's just obvious the other one gets cut exactly at that point. But when you have angled lines, you're doing a kind of a slope intercept problem, and you wind up with rational numbers there, where things that are not going to evenly land on an integer or even on any fixed point value that you've got. So everything winds up having to snap to some fixed point value. So the lines slightly change their angle. You wind up, if you cut something here, this one's going to bend a little this way, and it's not going to be completely straight. And then you come down to all these questions of, well, this one is a point on an angled line. You can't answer that in finite precision unless you're doing something with actual rational numbers. And later on, I did waste far too much time chasing things like that. How do you do precise arithmetic with rational numbers? And it always blows up eventually, exponentially as you do enough.
So these kind of things are impossible with computers. So
they're possible. Again, there are paths to doing it, but you can't fit them conveniently in any of the numbers. You need to start using big nums and different factor trackings of different things.
So you have to, if you have any elements of OCD and you want to do something perfectly, you're screwed if you're working with floating point.
Yeah.
So you had to deal with this for the first time.
And there were lots of challenges there about, like, okay, they build this cool thing, and the way the BSP trees work is it basically takes the walls and it carves other walls by those walls in this clever way that you can then take all of these fragments, and then you can for sure from any given point get an ordering of everything in the world, and you can say this goes in front of this, goes in front of this, all the way back to the last thing. And that's super valuable for graphics, where kind of a classic graphics algorithm would be Painter's algorithm. You paint the furthest thing first, and then the next thing, and then the next thing, and then it comes up and it's all perfect for you. That's slow because you don't want to have drawn everything like that, but you can also flip it around and draw the closest thing to you. And then if you're clever about it, you can figure out what you need to draw that's visible beyond that.
And that's what BSP trees allow you to do.
Yeah. So it's combined with a bunch of other things, but it gives you that ordering. It's a clever way of doing things. And I remember I had learned this from one of my graphics Bible at the time, a book called Foley and Van Dam. And again, it was a different world back there. There was a small integer number of books. And this book, this book it was a big fat college textbook that I'd read through many times. I didn't understand everything in it. Some of it wasn't useful to me, but they had the little thing about finite orderings of you draw a little T-shaped thing and you can say you can make a fixed ahead of time order from this, and you can generalize this with the BSP trees. And I got a little bit more information about that. And it was kind of fun later while I was working on Quake. I got to meet Bruce Naylor, who is one of the original researchers that developed those technologies, as for academic literature. Mm-hmm. And that was kind of fun. But I was very much just finding a tool that can help me solve what I was doing. And I was using it in this very crude way in a two-dimensional fashion rather than the general 3D. The Epsilon problems got much worse in Quake in 3-dimensionals when things angle in every way. But eventually I did sort out how to do it reliably on Doom. There were still a few edge cases in Doom that were not absolutely perfect, where they even got terminologies in the communities. Like when you got to something where it was messed up, it was a Hall of Mirrors effect, because you'd sweep by and it wouldn't draw something there, and you would just wind up with the leftover remnants as you flipped between the two pages. But BSP trees were important for it, but it's again worth noting that after we did Doom, our major competition came from Ken Silverman and his build engine, which was used for Duke Nukem 3D and some of the other games for 3D Realms. And he used a completely different technology, nothing to do with BSP trees. So there's not just a one true way of doing things. There were critical things about, to make any of those games fast, you had to separate your drawing into, you drew vertical lines and you drew horizontal lines, just kind of changing exactly what you would draw with them. That was critical for the technologies at that time. And like all the games that were kind of like that wound up doing something similar. But there were still a bunch of other decisions that could be made. And we made good enough decisions on everything on Doom. We brought in multiplayer significantly, and it was our first game that was designed to be modified by the user community, mm-hmm. where we had this whole setup of our WAD files and PWADs and things that people could build with tools that we released to them, and they eventually rewrote to be better than what we released. But they could build things, and you could add it to your game without destructively modifying it, which is what you had to do in all the early games. You literally hacked the data files or the executable before, while Doom was set up in this flexible way so that you could just say, run the normal game with this added on top, and it would overlay just the things that you wanted to there.
Would you say that Doom was kind of the first true 3D game that you created?
So no, it's still, Doom would usually be called a 2.5D game, where it had 3-dimensional points on it. And this is another one of these kind of pedantic things that people love to argue about what was the first 3D game. I still, I'm like every month probably I hear from somebody about, well, was Doom really a 3D game or something? And I give the point where characters had 3 coordinates. So you had like an X, Y, and Z. The Cacodemon could be coming in very high and come, mm-hmm. And come down towards you. The walls had 3 coordinates on them. So on some sense, it's a 3D game engine, but it was not a fully general 3D game engine. You could not build a pyramid in Doom because you couldn't make a sloped wall, which was slightly different, where in that previous Shadowcaster game, I could have vertexes and have a sloped floor there, but the changes that I made for Doom to get higher speed and a different set of flexibility traded away that ability, but you literally couldn't make that. You could not, you could make different heights of passages, but you could not make a bridge over another area. You could not go over and above it. So it still had some 2D limitations to it.
That's more about the building versus the actual experience, because the experience
it felt like things would come at you, but again, you couldn't look up either.
Right.
You could only pitch. It was 4 degrees of freedom rather than 6 degrees of freedom. You did not have the ability to tilt your head this way or pitch up and down.